Welcome to the session. I am Shaktimani, ECE department in M. Kumarasamy College of Engineering. Next we are going to see about our topic is electromagnetic waves between parallel planes. See, this is parallel planes. There are two parallel planes. In electromagnetics between parallel planes, we are used to find electric field strength Ex and Ey and magnetic field strength Hx and Hy. Now we will see about how we will derive these four equations. First we see the del cross H is equal to j omega epsilon E. This is from Maxwell equations. Del cross E is also minus j omega mu H. These two equations comes from Maxwell equations. The another formula also is there. Del cross H is equal to, there are 3 rows and 3 columns, Ax, Ay, Az, like first row, second row, third row. By this matrix we can derive the j omega epsilon into Ax, Ex plus Ay, Ey plus Az, Ez. Then by this matrix we can derive the dou Hz by dou y minus dou Hy by dou z is equal to j omega epsilon Ex. J omega epsilon Ex comes from, that is del cross H is equal to j omega epsilon E. So that is Ex. Likewise Ey, Ez. This is number equation 1. Then del cross E is equal to, again similar derivation for del cross E also. 3 rows Ax, Ay, Az and second row, third row. Likewise we derived, we know that the matrix in Ax, then like this. Then finally minus j omega mu into Ax Hx plus Ay Hy plus Az Hz. This is derived from del cross E matrix. In this matrix we can derive it again by these two formulas, that is del cross E is equal to minus j omega mu H with the help of minus j omega mu Hx, Hy, Hz. Right hand side and left hand side write like this. Then these are all the two equations, equation 1 and equation 2. Again the wave equation is given by, we know the formula for wave equation, del cross E is equal to gamma square E and del cross H is equal to gamma square H. These two wave equations. By using these wave equations we can write like this: del cross E is equal to minus omega square mu epsilon E. Like gamma square, we know the formula, sigma plus j omega epsilon and into j omega mu. We can multiply by get this equation like this. Del cross H also we can write like this. Again is equal to, right hand side we can write like this, minus omega square mu epsilon E and right hand side minus omega square mu epsilon H. Left hand side we know the del square E, we can write like this, dou square E by dou x square plus dou square E by dou y square plus dou square E by dou z squares. Okay, equation 1 and equation 2 and equation 3. The first two equation comes from Maxwell equation. By using the Maxwell equations, first two equations, and third equations, this is wave equations. Okay, fine. Now only one conditions. Now we can consider y directions, that is y derivatives 0 and x derivatives keep in x derivatives, and we can find only z derivatives. There are 3 derivatives: x derivatives, y derivatives, z derivatives. Y derivatives that value is 0 and z derivatives we can keep it in this. So we will find the z derivatives, dou Hy by dou z and dou Ey by dou z. And see, wait a minute, yes, dou Hy by dou z and dou Ey by dou z and dou Ex by dou z, dou Hx by dou z. These are all the z derivatives, and y derivatives put 0 and x derivatives keep it. So finally we substitute these 3 conditions: x derivatives, yes, dou Hz by dou x, like this, dou Hy by dou x. This is just keep it this, and y derivatives put 0. Only we can substitute z derivatives. So these 3 conditions substitute in above 3 equation. Equation number 1, equation number 2 and equation number 3. we can substitute three conditions. X derivatives just keep it, and y derivatives put 0, and z derivatives some formula, some equation we find. So use these equations, we can substitute. So we will get equation 1 becomes equation 4, equation 2 becomes equation 5, equation 3 becomes equation 6. Okay, by using this 4, 5, 6, this equation we can find to solve Hx, Hy, Ex, Ey. We already said that in this questions we can find electromagnetic field strength, that is Ex, Ey, and magnetic field strength, that is Hx, Hy. Okay, we will use equation 4, 5, 6 Hx to solve Hx value. See, minus gamma Hx, yes, equation 4, the second row, minus gamma Hx minus dou Hz by dou x j omega epsilon Ey. You just take it this equation, then gamma Ey in equation 5, first row, gamma Ey is equal to minus j omega mu Hx. Yes, it is there. We will take these two equations. With the help of two equations we can substitute Hx, that is Ey value, in this equations. We will get see Hx value like minus gamma H square by dou Hz by dou x. Similarly, we can derive Hy, Ex, Ey like this. See, Hs equal to minus gamma by j omega mu into 1 minus 1 by j omega epsilon into gamma Hx plus dou Hz by dou x. See, take outside minus 1 by j omega epsilon e, then get like this. Then left hand side we will take 1 plus gamma square by Hx, we will take outside like this. We will get the equations. So finally get the answer like this. Hs is equal to minus gamma by H square into dou Hz by dou x. Similarly, we derived Hy value. This is from equation 5, equation 4. With the help of two equations we will find Hy value. So we can write like this. Hy is equal to j omega epsilon by gamma into Ex. Then Ex is equal to, here 1 by gamma, take right hand side. So denominator 1 by gamma into like this, j omega mu Hy minus dou Ez by dou x. So Ex and Hy. See, Hy is equal to like this. So we can substitute Ex value in Hy equations. So like this we can get. Then multiple with these terms. The first term, j omega epsilon by gamma square, we can multiple inside the terms. Like this we will get minus omega square mu epsilon E into Hy divided by gamma square minus j omega epsilon divided by gamma square into dou Ez by dou x. This is like this. Then Hy term took left hand side, Hy take outside. Finally we will get answer like this. Hy is equal to minus j omega epsilon by H square into dou Ez by dou x. Similarly we will, that is, still now we can found Hx and Hy value, that is magnetic field strength, Hx and Hy. Now we will see Ex and Ey value, that is electric field strength. Now again with the help of equation number 5, equation number 4, we can write like this. Then gamma Ex plus dou Ez by dou x is equal to j omega mu Hy value. We know that the Hy value we can substitute directly. Then left hand side take all Ex value, then Ex take outside common, then Ex is equal to minus gamma by H square into dou Ez by dou x. That is electric field strength Ex value. Now we will find Ey value. Again from equation number 4 and 5 we will take like this. Similarly, minus gamma square Ey by j omega mu plus dou Hz by dou x is equal to minus j omega epsilon Ey. That is Hx value we can substitute here. Then take left hand side Ey, all the terms, and take outside Ey value. Finally we will get answer like this. Ey is equal to j omega mu by H square into dou Hz by dou x. Okay, that's all about these derivations Ex, Ey, Hx, Hy. Okay, what all the done this derivation we will see again once again. See, the equation number 1 comes from Maxwell equations, that is del cross H is equal to del cross E is equal to. There are two formulas and del cross H in matrix form. Similarly, we can get like this equation 1. Equation 1 get from del cross H and del cross H. These two formula with the help of del cross H j omega epsilon E and del cross H matrix form, with the help of these two equations we will get equation number 1. Similarly, del cross E in matrix form and formula from Maxwell equation minus j omega mu H. With the help of these two equations we will get equation number 2, and equation number 3 we will get wave equations, that is del square E is equal to gamma square E. Del square we can write like this: dou square E by dou x square, dou square E by dou y square plus dou square E by dou z square. On right hand side minus omega square mu epsilon E. Similarly, we can write del square H also. This is equation number 3. See, equation 1 will get 3 equation, equation 2 will get 3 equation, equation 3 we will get 2 equation. Totally 8 in 3 equation contains 8 equations. See, now we will apply 3 conditions in above 3 equation. Now apply 3 conditions. Because alpha is real, that is beta equal 0, there is no wave motion but only an exponential decrease in amplitude. So we can use only z derivatives. So we will find z derivatives value. See, z derivatives means what? Dou hy by dou z and dou ey by dou z, dou hx by dou z, dou ex by dou z. Consider hy is equal to hy power 0 into e power minus gamma z. This is the common term. So we will differentiate with respect to y. We can get like this. Similarly, dou hx by dou z, dou ey by dou z, dou ex by dou z. These are all the z derivatives. So these 4 z derivatives value substitute in above 3 equations, and x value just keep it is. Just keep dou hz by dou x. Where it is x values, dou ez by dou x, dou ey by dou x, dou hy by dou x. Just keep it this. And y derivatives put 0. So here see the first equations. These are all the y derivatives, put 0. These are all the y derivatives, put 0. X derivatives just keep it this. Z derivatives only we have to substitute. Like this equation 1, equation 2 also. See, y derivatives put 0 and x derivatives just keep this, and z derivatives, these are all the z derivatives. Z derivatives only we have to substitute. We already derived, that is hy is equal to hy by 0 e power minus gamma z. With the help of these equations we can derive z derivatives. This is equation number 2. Equation number 3, similar concept we will apply. These 3 conditions. What are the 3 conditions? X derivatives just keep this, y derivatives put 0, z derivatives only we have to substitute. Substitute these above 3 conditions, we will get like equation 4, 5, 6. Equation 4 comes from equation number 1. See the equation number 1. Yes, first y derivatives put 0, z derivatives will just substitute. See, z derivatives value minus gamma hy minus plus, so plus gamma hy is equal to right hand side. Right hand side simply we can write like this: j omega epsilon ex. See, j omega epsilon ex. Like this we can substitute 4, 5, 6. We will get this answer like this. Then with the help of equation 4, 5, 6 to find magnetic field strength, that is hx and hy, and electric field strength ex and ey. Yes. Okay, fine. I think this derivation is over. Okay. Thanks to all.